Hello friends, welcome to the series of lectures of Mathematics 1. Myself Hardik Patel from LJ Institute of Engineering and Technology. Now in today's session we are going to start with the topic Fourier Series, and today we are going to cover introduction of the Fourier Series. Now first of all, Fourier Series is used in the analysis of periodic function. Secondly, many phenomena in engineering and sciences are periodic, such as a current, voltage in AC and voltage in AC circuit, correct? So these are the periodic function or wave functions, some of the waves such as triangular wave, rectangular wave, and so on so on. Now, if you have given any phenomenon which is periodic, then the Fourier series decomposes the periodic function into the sum of sine and cosine functions. Sum of sine and cosine functions. Okay. The computation and the study of the Fourier series is known as a harmonic analysis. That means whatever the computation we have done is called a harmonic analysis. Now, it has a many application in electrical engineering, vibration analysis, acoustics, optics, signal processing, and image processing. Okay, so please remember that. So these are the basic concepts which we are going to simply required for the Fourier series. Now, first we are going to define the periodic function. A function is said fx is said to be periodic function for all x if there exists some positive number p such that f of x plus p is equal to f of x. Then we are going to say that the given function f of x is periodic, and p is such a smallest number for which this is going to be happen now. Okay, the p is called the period of a function f of x. Now, the smallest positive value p is called the fundamental or the primitive period of the given function f of x. It may happen that you have more than one periods. In that case, whatever the smallest period we have, it is called the fundamental period. For example, suppose sin x, cosec x, sec x, these all are periodic functions that we are already aware of. And they have a fundamental period 2 pi. Because see, sin 2 pi plus theta is sin theta, sin 4 pi plus theta is also sin theta, sin 6 pi plus theta is also sin theta. That means in general 2k pi plus theta is also sin theta. But the minimum value is 2 pi. That's why 2 pi is a fundamental period. Now tan and cot are also periodic function, but they have a period pi. Okay. So please remember that, because tan pi plus theta is tan theta, cot pi plus theta is a cot theta. In general, if you are find the period of a function f of x is equal to a sin bx plus c, a into sin of bx plus c plus d, then the formula of period p is equal to 2 pi upon mod b. Okay, where b is nothing but it is a capital B is nothing but it is a coefficient of x in a angle. Now we are going on to the Dirichlet condition. See, Dirichlet condition is the condition which is required for a Fourier series. If function is satisfying this condition, then only we are going to find the Fourier series, otherwise it is not defined. A function fx defined on interval c to c plus 2l can be represented as a Fourier series if it satisfies the following conditions. The first condition, fx is periodic. That means the function must be periodic function, and f of x plus is equal to f of x plus 2l, where 2l is a period of a function. That means we are defining the function which is periodic on interval c to c plus 2l with basic difference of period. Okay. Secondly, fx and its integral are finite and single valued. That means functions integral and whatever the functions integral you have, that has a finite value and a single valued function. You cannot get more than one value for that integration. Okay, a function fx is called single value if for each point in a domain it has a unique value in its range. Okay, same manner third condition is fx is a finite number of discontinuity. That means your function is piecewise continuous on interval c to c plus 2n. So that suppose you have any curve and it has a more than one break, then it is okay. But if it must have a finitely many discontinuity. If you have infinite discontinuities, then you cannot find the Fourier series. And the last condition, fx has a finite number of maximum and minimum. That means function must have a finite number of maximum and minimum in the interval. If these conditions are satisfied, then these conditions are called the Dirichlet conditions. Okay, then you can find the Fourier series. Now, example we have written is f of x is equal to 10x cannot be expressed as a Fourier series because see, it is unbounded function. Why? 10 of pi by 2 has a value infinite. So, that function is unbounded. So, if you are going with a interval suppose 0 to pi, then function is not defined at pi by 2. Correct? Same manner sine inverse x. If you are going with a function sine inverse x on some interval suppose 0 to 3, then in that case inverse function sine inverse 0 has a value n pi and n has any value from greater than 0. So it is a multi-valued function. That means it is not a single valued and that's why you cannot find the inverse of this function. Same manner f of x is equal to sin x. Now this is a simple function. So this can be expressed as a Fourier series because see it satisfies all condition of Dirichlet. Okay. So please remember all the conditions of Dirichlet must be satisfied. Now generally it is not required to check the conditions if the function is given in a simple form or it is a polynomial function. Okay. And exponential function or they all are a simple function. So in that case it is not required. Now Fourier series of a function with a period 2l. Okay. Now first we are going to define the Fourier series for a 2l periodic function. Suppose let fx be any function with a fundamental period 2l. Then on interval c to c plus 2l, we are defining the Fourier series. Then it is given by fx is equal to a0 by 2 plus sigma n running from 1 to infinity an cos n pi x upon L plus bn sin n pi x upon L. So please remember that whenever you are going to find the Fourier series of any function like this, then 2L is a fundamental period, then you require to find what is the value of L and using L, you have to put all values of A0, An and Bn and you have to put the value of L here. Okay. Now, where A0 is given by 1 upon L c to c plus 2L fx dx. That means whatever the interval you have, on that you have to integrate your original function and divide it with L. Same manner if you are finding an, then it is 1 upon L c to c plus 2L fx into cos n pi x upon L dx. And same manner bn will be 1 upon L c to c plus 2L fx into sin n pi x upon L dx. That means in A0 you have only function, in An you have fx into cos n pi x upon L, in Bn you have fx into sin n pi x upon L. Okay, and one you have to divide each term with L. This will give you the values of A0, An and Bn and put these values in the equation number 1 that will give you the Fourier series of a given function fx in a form of sine and cosines. Okay, so once this equation number 2, 3 and 4, whatever they are called the Euler's formula. Okay, equation number 2, 3 and 4 are called the Euler's formula. Also they are known as a Fourier coefficients. Okay, they are known as a Fourier coefficients. Now prerequisite things. We are starting with the prerequisite things. First, with some of the derivatives and some of the integration we are going to revise today. and then we are going to start with the some basic examples of integration. So first one is d by dx of x raised to n is n into x raised to n minus 1, correct? The same manner, the integration of x raised to n is x raised to n plus 1 upon n plus 1 plus c, provided that the value of n is not equal to minus 1, correct? Same manner, sin nx has the integration minus cos nx upon n plus c. Same manner, cos nx has the integration sin nx divided by n plus c, correct? That means you have to divide with the coefficient. Then we are going on to the integration by parts. Now in integration by parts, you have learned the simple formula integration u into v dx, that is equal to u into integration v dx minus integration of break into the bracket du by dx into integration v dx whole dx, correct? So this is your the formula of integration by parts. Now we are going to use here the rule of Liet. That means first we are going to consider u as a logarithm function. Secondly, it is inverse. Thirdly, it is algebraic. Fourthly, it is trigonometric. And last one, it is exponential. That means this is the order of u. If you have function log into x, then u is going to be a log x, and x is going to be a v. So this is the basic concept that you have learned. And the generalized form of integration by parts is integration of u v dx is equal to u into v1 minus u dash into v2 plus u double dash into v3 minus u triple dash into v4 plus so on, so on, so on. Here v1, v2, v3, v4 are first, second, third, fourth integration of v, and u dash, double dash, triple dash are their first, second, third derivatives of original function u. Okay, and you can continue this until the derivative is going to be 0. So the generalized form is generally useful whenever the derivative of u is going to be 0 after some finite derivatives. Otherwise, this generalized form is not going to be help out. Okay. Now we are going with one example. Suppose you have given integration x square into sine 3x dx. So if you are going to start with the rule of Liet, then first one is a logarithm, second one is a inverse, third one is arithmetic. So here your x square is a arithmetic term, correct? Fourth one, so this one is going to be u and this one is going to be v. First, whatever the term you have, that will be a u, and secondly it is going to be v. Now we are going to use the generalized form of integration by parts. So for generalized form, what you have to do, first you have to put u as it is, that means x square as it is, and integration of sine 3x. So integration of sine 3x minus derivative of x square. So x square has a derivative 2x into the integration of sine 3x is whole integration of sine 3x dx. Okay, then plus derivative of 2x has a value 2. And the again integration of this term, that means integration of sine 3x dx dx dx. Here it is dx. Okay. Now again then you have to put minus, but minus 2 has a derivative 0, so that all the terms after these terms are going to be 0, correct? And since you have a polynomial function, so after finite terms all the derivatives are going to be 0. So in this case you can apply the direct formula, that means you can apply the continuous integration by parts. Now we are simplifying this, then x square as it is, sine 3x as the integration minus cos 3x divided by 3 minus 2x into sine 3x as the integration minus 3 sin x divided by 3, and again integration of this term, that means minus sine 3x divided by 3 into 3. That means you have now 9. Okay. Then the third term will be plus 2 into, again integration. Double integration has a value minus sine 3x by 9. And integration of this term. That means sine has an integration minus cos. So minus minus plus cos 3x divided by 27, because 9 into 3. Correct? So if you are going to write down in a simple form, then you will have minus x square cos 3x divided by 3 minus minus plus 2x sine 3x divided by 9 plus 2 into cos 3x divided by 27. Okay. So this is the answer of this example. Same manner, now the integration of e raised to ax into sine bx is nothing but e raised to ax divided by a square plus b square into the bracket a sine bx minus b cos bx plus c. Same manner, instead of sine, if you are going with e raised to ax into cos bx dx, then it will be a e raised to ax divided by a square plus b square into the bracket a cos plus b sine bx plus c. Please remember that here a and b are nothing but they are the coefficient of in the power of x and in an angle of sine or cos. Okay. Now we are going on to 2SC or 2CS or 2CC or 2SS. So 2SC, that means to sine A cos B, that will be a sine A plus B plus sine of A minus B. Same manner 2CS, that will be a sine A plus B minus sine A minus B. Same manner cos A 2CC, that means 2 cos A cos B, that will be a cos A plus B plus cos of A minus B. And last 2 sine A sine B, that will be a minus of cos A plus B plus cos of A minus B. And same manner cos A plus B, that means cos alpha plus beta, that will be a cos A cos B minus sine A sine B. Then cos A minus B is equal to cos A cos B plus sine A sine B. Please remember that in cos you have a opposite sign. If here you have plus, then here you have minus, here you have minus, then here you have plus. And sine of A plus B, that will be a sine A cos B plus cos A sine B. Same manner, sine of A minus B, that will be a sine A cos B minus cos A sine B. Correct? So, okay, now we are going on to the sine of minus theta. That will be a minus sine theta. And cos of minus theta, that will be a cos theta. Okay, that means in sine you have to write down minus outside. In cos you have to neglect it. Sine 0 has a value 0. This is very important. See, sine 0 has a value 0, sine n pi has a value 0, and sine 2n pi has a value 0. Correct? Now, we are going with a cos. Cos 0 has a value 1. Cos n pi has a value minus 1 raised to n. And cos 2n pi has a value 1. Please remember, see, you have to remember these values, because we need these two values to put in a Fourier series. Okay. Now integration of e raised to ax, that will be e raised to ax upon a, and derivative of e raised to ax, that will be a into e raised to ax. Sine square will be replaced with a 1 minus cos 2x by 2 for integration purpose, and cos square will be replaced with 1 plus cos 2x divided by 2. Okay. Same manner, derivative of a constant is always 0, and integration of constant is constant into x plus c. Correct? So these are the topics which we have covered in today's session regarding the Fourier series. If you have any doubt or any query regarding these topics, then please feel free to contact me. Thank you so much.